はい、皆さんこんばんは。今日はお越しいただきありがとうございます。ポルカドットチームと Web3 ファウンデーション、そして皆さんと今日はニュートリノで時間を共にすることができてとても嬉しく思います。暗号通貨ブロックチェーンマーケットもちょっとフェーズが移りつつある段階ですけど、今日また一つ皆さんといいミートアップができればいいなと思います。で、今日のタイムスケジュールなんですが、一番最初に、ライアンの方から Web3 の未来というもので、15分程度お話ししていただきます。で、その次にロブの方から、ポルカドットのデベロッパーのロードマップですね。ロードマップなどをお話ししていただきます。で、その後、二ギャビンの方から、サブストレート、ポルカドットのテクニカルサイドについてお話ししていただき、最後に、アルの方から、そうですね、ポルカドットのさらにコンセンサスアルゴリズムとファイナリティのところに掘ってお話をしていただきます。で、その後 QA セッションを挟んでネットワーキングイベント、今日寿司をオーダーしておきました。はい。という形でやっていきます。So, thank you for coming today. I'm so honored to have Polkadot and Web3 Foundation and you at Neutrino. So, there are 4 sessions and 1 networking session and networking session. So, let's get it started. Please. And this one.
Awesome. Thanks very much for having us. I appreciate all the effort from Neutrino Japan and to all of you for coming out. And I'll just quickly walk through basically the state of Web3 and where we're at today. So what is Web3? Web3 is Gavin Wood's vision for a decentralized serverless internet where users have control over their own privacy, their own identity, their financial accounts, and effectively their own destiny. Where decentralized peer-to-peer networks leverage trustless incentivization through a crypto economic design. And why do we call it Web3? We call it Web3 because this is the third sort of major evolution of the internet. We started out with Web 1, which was static read-only websites, HTML, effectively no monetization and really poor UI UX. As we moved through into Web 2, websites became more dynamic, user-generated content was easier, and platforms proliferated. Monetization, though, stayed kind of in the Stone Age and was mostly based on data sales and advertising. Social and mobile popped up, but we have massive issues with privacy, with data breaches, and a massive consolidation of wealth and power on the internet today. But we're at the dawn of a new era in the internet, and the re-decentralization and the return to the founding values of the internet, where decentralized applications built on WebAssembly virtual machines allow people to have greater control over their destiny on the internet. Monetization is built directly into the protocols. Users are able to control their own data and their own privacy, and we have a much better distribution of wealth and power on the internet. Even crypto networks today have much higher Gini coefficients than, say, what we see with the world at large. So why does this matter? It matters because Web 2 has failed us. We have a small cartel of companies that control the massive majority of cloud compute and cloud storage on the internet. The FANGs, so Facebook, Amazon, Netflix, Google, control the vast majority of your personal data, and they commercialize that data as they see fit without involving you in the process. And then again, Web 2 monetization really missed the mark. For all of the innovation that has popped up on the web, we're still stuck with mostly advertising-based business models, or more recently, data mining and data sales on behalf of these platforms. Frankly, we deserve better. We deserve an internet where we have more control, and we deserve to participate more in the commercialization of our data. So some just interesting kind of cultural components of Web3 and what we're driving for. So we're of the belief that governance is a noble pursuit, and on-chain governance is definitely the direction forward for our ecosystem. We can create borderless public goods commons and have representation of all the constituents in a network. I'm of the personal opinion that we need more safe spaces for experimentation and innovation, where we can upgrade some of these networks and test and deploy different crypto economic theories in order to stay at the vanguard of technology. We're very early on in Web3, and we need to be able to continue to innovate. And what we've seen in communities like Bitcoin and subsequently Ethereum is, as value has increased, and that's natural because markets are leading indicators and often outstrip technology, the innovation has slowed down, unfortunately. And then we have massive issues around sort of the classical trilemma of blockchain: scalability, privacy, and decentralization. And this requires a new architectural approach. So enter Polkadot. Polkadot is interoperability infrastructure for Web3. This connects disparate blockchains with one another and allows for arbitrary message sending and smart contract calls between decentralized networks. It's an incredibly ambitious project, allows for parallelized security, and as I mentioned, arbitrary smart contracts and message across chain. It's a hybrid consensus, which allows for fast finality, however, sufficient security and decentralization. And then governance will guide the innovation and allow our community to make reasonable decisions and move forward without debate going on endlessly. And then one of the things that excites me most about this project is that it's led by the team at Parity. And I've spent the last 5 years in this space mostly evaluating teams and deploying capital based on my evaluations. And upon looking around the space and basically talking with most of the teams doing interesting work in the space, I very safely conclude that this is unquestionably the deepest technical bench in the space, and in my opinion, the most talented team. Where many teams have a few really strong engineers, this team is 50 deep of some of the leading minds in the space and pushing the vanguard of this industry. So quick overview of what Polkadot is. So the base chain of Polkadot, we call it a relay chain. And then on top of that chain sit other parachains. Now, parachains can be chains that are built using a web or to compile down to a WebAssembly VM. They can be built using Parity substrate, so that they basically interact with the relay chain natively. Or if they're a legacy chain, say like Zcash, then they'll require a bridge. And both of those options are doable, with the caveat that parachains are much faster or much better performance overall on the Polkadot network. One of the amazing advantages here is parallelization of security, and this is a very significant advantage in achieving scalability. When you have isolated security, say proof of work, there has to be a decision made about where to direct resources, whereas with shared security on Polkadot, multiple chains can tap sort of the same validator set for validation. Sorry about that. Another thing that is extremely exciting for me as an observer of the space is the very aggressive roadmap from this team. To my knowledge, no major undertaking in the history of our industry has ever shipped mainnet on time. And right now, Polkadot is scheduled to be the first project to ever ship actually ahead of schedule, and that's an incredible feat. Again, a first for the industry. So, we're going to see this sometime in probably Q3 of next year, and I think given the novel consensus, given the governance, given native light clients and how easy it will be to build on Parity substrate, this is certainly the most exciting ecosystem. We're starting to see just this community groundswell, somewhat similar to what we saw kind of in 2015 or 2014, 2015 around Ethereum, where people are coming together and just wanting to experiment and innovate and push the space forward. And they're sort of done with the debates and vitriol of other ecosystems. So cool stuff already being built on Polkadot. As I mentioned, parity substrate. So this is a framework or sandbox for building parachains. Highly adaptable, offers native light client very easily. Governance, it's a really easy on-road for parachains. So basically what this is like a virtual machine and blockchain in a box. Today, if you're building a new chain, you can abstract away the lower layer part and just focus on what your innovation is, whether it's some privacy measure or some consensus mechanism. You can kind of focus on that, build this on substrate, and allow the VM and that kind of low level component around the blockchain be done for you. So it allows you to deploy this more quickly and focus exactly on what is your innovation. Again, built using the sort of best-in-class technology, WebAssembly virtual machine, libpdp for libraries. It's Rust-based, but there will also be a JavaScript implementation over time. And in fact, as an observer, I would say there'll probably be a number of other implementations over time. And to the extent that someone here is interested in working on something with respect to implementations or building a chain on substrate, come and find us and chat with us. We're here to help. Edgeware, which Dylan will talk about a little bit more. I won't touch on this too much. It's a test net with real financial incentives in order to test new governance mechanisms. I'm personally incredibly excited about this project, just because we spend so much time debating governance, and I would prefer to spend more time testing it and pushing governance forward. Again, it's my opinion that governance is the obvious path forward for our space. It's a noble pursuit in and of itself, and we need this. And so, in needing this, we can't just throw the governance kite in the air and hope that it flies. We need to test governance in a safe space, and that's why the parachain architecture really makes sense. Other collaborations, so many projects from Zcash to libpdp, which is Protocol Labs, Polkascam, which is a block explorer, and Blink, which is a DAG, a very fast transaction throughput. Agoric, which is Mark Miller's JavaScript smart contracting platform to write reasonably secure smart contracts in JavaScript. There's a number of really compelling projects that have already declared that the best space for them to build is in the Polkadot ecosystem. And community is strong and growing. We just had an amazing event in October, which I think was the best conference of the year, called the Web3 Summit. And we're active in a number of communities around the world, including here. The turnout here tonight is fantastic, and I thank you all for coming out and listening. So if you have any questions, comments, or you want to reach out and jam on some concept or discuss how you can get more involved, these are a number of ways to connect. So thanks very much. Thank you.
Thank you, Ryan. はい、ちょっと順番を変えまして、次ドクターギャビン・ウッドさんにお話していただこうと思います。もう説明はいらないと思うんですけれど、ドクター・ギャビン・ウッドさんはイーサリアムの元チーフテクノロジーオフィサー兼共同創業者ですね。イーサリアムのプロトコルの共同デザイナーであり、イーサリアムの、プログラミング言語であるソリディティのデザインの、開発責任者も務められています。So, please welcome Gavin Wood. I think.
this one? This one to this one?
Oh, for the clicker.
Yeah.
Cool.
Hello. Sorry. Okay.
Finally, we're in.
Yeah. Okay. Cool. Right. Thanks for coming. It's always nice to be in Tokyo. One of my favourite places to visit. It's so fun. So much to look at and do. Great. Yeah. So I want to. I'm not going to take too much of your time. I'm just going to talk. Give you a bit of an introduction to Polkadot, particularly the governance bit, and let you know where my thoughts are for governance on Polkadot and maybe Substrate at the moment. So yeah, Polkadot is an example, one of the projects that you might reasonably call blockchain 3.0, right? If Bitcoin was sort of 1.0 and Ethereum, etc., were sort of 2.0, then we're kind of onto the third wave now. And the sorts of things that these projects have, governance, scalability, are the two sort of really big ones. Also some idea of future-proofing, like, can we make a 3.0 chain that lasts all the way into 4.0 and 5.0 and beyond? Developability, not many people think about this so much, but how easy is it? How fun is it to actually code on? How fun is it to develop applications on these things? Interoperability, so letting different 3.0 projects talk to each other, and efficiency, which basically means can it work on mobile? As far as us at parity goes, our 3.0 tech stack basically has Polkadot Substrate in the middle. Right. Below Substrate, we work on Rust, and also WASM, WebAssembly, our interpreter for that, and libp2p, which lets nodes communicate with each other in a reasonably modular way. You'll notice the diagram's a little bit confusing, with Substrate appearing both there and at the top. That's a feature that allows us to both build Polkadot on Substrate and use Substrate as a way of creating chains on top of Polkadot. And therefore, because Polkadot is built on Substrate, it means, in principle, we can evolve so that even Polkadot can be built on top of Polkadot. And when we can do that, then we can solve quite a lot of problems. The goals of Substrate, which is basically the tech stack on which we'll build Polkadot, are to be adaptable and upgradable, so that we've got this upgradability, so we can move forward. We can deploy and assimilate technology beyond which that was available when we wrote the thing. The idea is to have a first-class light client, as Ryan said. And a progressive and also generic. In principle, you can change the consensus algorithm even in real time as the chain is going. But we have a consensus algorithm that we like, that I think Alistair's going to talk about in a bit. That's quite novel and has some really nice attributes. But the thing I'm going to talk about is the governance bit, because that's what I've been working on recently. As Ryan said, there's already a Rust implementation, that's the primary one. There's a JavaScript implementation as well, and we're more than happy to chat to other teams if there's anyone out there interested in doing their own implementation of this. We're all working on a specification already, so it's not too difficult to get started. Roughly speaking, the sort of overview, libp2p sort of sits at the bottom, helps with networking, and then if we imagine, sort of what code is dependent on what other code, we can see that consensus is sort of the lower the lowest level code that sort of sits on the networking and actually ensures that the different nodes remain in consensus, right? They all sort of agree on what's happened. Within the consensus thing, sort of we can imagine there's like a WebAssembly core, right? And that's the thing that informs the consensus about what the meaning of stuff that's happened. And then sitting actually within the WebAssembly thing is all of the interesting stuff, and that's actually compiled down to WebAssembly, right? So this is how it's upgradable. Because it's compiled down to WebAssembly, it's platform neutral, and it means that we can change out all of these bits even as the chain is ongoing, even as the chain is sort of moving along. We don't need to hard fork. We can actually just tell the chain, hey, turns out that that we want to add a new feature onto the chain. We want to add permissions, or we want to remove permissions, or we want to add smart contracts, or we want to add a particular feature of smart contracts, and we can do that. And the reason that we can do that is because all of this logic is stored on the chain in a platform neutral and completely unambiguous way. So we've so far released 2 proofs of concept, so 2 milestones. Yeah, we've been working for about a year, and we're about to release our 3rd milestone, which signals about 3/4 of the way to feature completeness for our release. And the sorts of things that it's got going on, it's got ED 25519 for its crypto for authentication, using the Blake2B hashing algorithm, reasonably secure and fast. libp2p, as I mentioned before, we've got a pseudo-random number generator that's deterministic. We're using the collective coin flipping, although that might change, and it might even be that Alistair mentions that as well, I don't know. For our consensus algorithm, we are using a hybrid mechanism that combines 2 separate algorithms, one for doing the finality of blocks, called Grandpa. It was sort of going to be called Shaft, but we kind of ended up settling on Grandpa. I prefer Shaft myself, but I'm going to go with the opinion. So it's called Grandpa. Rob will tell you what that stands for. I don't know, I can't remember, it's too complicated. And that's for getting finality. So that's making sure that a block, once it's finalized, it never gets reverted. Now for production, which isn't, this is simply for putting out blocks and sort of suggesting them as the things that will be finalized, but not actually finalizing them. We use a technique called ORAND, which is sort of short for authority round but random, randomized. And it's a sort of thing that basically makes it more or less the same as proof of work. Sort of randomized miners, virtual miners are chosen based upon how much is at stake, how much they place at stake. So there's no actual mining, but it sort of simulates mining to some degree. And we have a Bitcoin-like address format, although we also introduce address indexing, which means our account addresses can be very, very small. They're about 5 alphanumeric characters compared to Bitcoin's, I don't know, what is Bitcoin like, 16, 14, 15, 16. And we have a very nice generic modular system for building functionality into the chain, which is sort of beyond the scope of this talk, but if you look up Substrate online, you'll be able to sort of dive into that. One sort of quick thing to point out, even though our blockchain and Substrate sort of Polkadot blockchain runs in WebAssembly, most of the logic is in WebAssembly, it's not actually slow, because what we're able to do is provide native equivalent code. So what it can recognize based by versioning, whether the native equivalent code that it has compiled for the computer that it's running on is equivalent logically to the WebAssembly that's stored on the chain, that's the sort of canonical, the real, the correct code. And if it is correct, if it's the same thing, then it actually just runs the native code, so it ends up being no slower than native anyway. But if it's not correct, if for whatever reason, maybe it's running an old version of the executable and the chain was recently upgraded, then it will fall back on the WebAssembly, which is slower but correct. Okay, so governance. So the key ingredients to our proof of concept 3 governance are referenda, so we have lots of referendums, adaptive quorum biasing, which I'll go over in a second, the council, which is sort of like sort of like a board of directors, if you like. Lock voting, which is to do with basically taking stake and locking it for a period of time. The longer that you lock your stake and the more stake that you lock, the greater your sort of voting power, right? So it's not simple coin voting, there's a bit more to it. Approval voting, which is a well understood mechanism for basically allowing a fairly rich expression of your preference about who should be, which of a number of alternatives should be elected. A treasury, which is basically like a very simple DAO, so you can put money into a pot and then you can come around and sort of spend based upon your opinions of which projects it should be spent on. And finally, delayed autonomous enactment, a kind of quite technical sounding term, but basically all it means is that once you've voted and you've decided that something should indeed, some proposal should be passed, you don't pass the proposal. The proposal doesn't get sort of enacted, it doesn't get brought about immediately. Rather, there's a waiting period, sort of a cooling down period, whereby everyone, perhaps that don't think it's such a great idea, can in principle divest themselves before the change actually happens. So it's sort of a means of reducing the possibility that the network will suffer, extremely contentious forks. This is it's a bit of a complicated diagram. It looks complicated. It's actually not. The bottom is the coin holders, right? So these are the token holders. These are the people that ultimately hold the sort of authority of the network. These are the. This is where our notion of what would you call it? These are the guys that basically make the decisions as a whole, as a group. Now, based upon a rotating approval vote, they populate and maintain a council. A council is a bunch of people, probably about 12, perhaps 24, that act as a sort of board of directors. And they can't make decisions on their own, they can't change anything on their own, right? But what they can do is they kind of have the power of the default if they act as a group, if there's consensus among them. They more or less allow us to determine whether a proposal is controversial or if it's not controversial. And we say that if a proposal has a unanimous council approval, so if everybody on the council thinks it's a good idea, then we say it's uncontroversial. And if most of them say it's a good idea, then we say it's perhaps, it's probably decent. And the difference between those two changes how we count the votes when it goes to referendum. But in all cases, all proposals have to be ratified by a referendum of these people, of these coin holders. Now, if these coin holders also can propose their own motions, public motions we call them, and when they do that, we count the votes in kind of quite a negative way, and we say, well, these motions, they haven't been sort of validated by the council, so they're potentially quite dangerous. And as such, we require a substantial quorum of voting and a majority before these will go through. When they go via the council, then we say, if it's the council sort of majority approves it as a good idea, then we don't require a quorum anymore. The council effectively counts as the quorum, and at that point it's just a majority. If the council is unanimous, so if we consider it an uncontroversial proposal, right, an uncontroversial change, and uncontroversial change will basically be a kind of technical upgrades, right? There'll be things that no one loses anything, right? Nothing really changes, no economic changes to this. Then in that case, we bias against the default, we bias against the status quo, and we require, if the no's are to win, if it's not to go through, then we require actually a substantial quorum plus the no's being the majority. And in that way, this is designed to kind of balance responsibility and safety alongside actual liveness. So actually keeping the thing moving, keeping the technology coming in, keeping up with other systems that personally I think existing blockchains don't do a great job of. So tabling referendum, as I mentioned, public proposals. If you're a member of the public, so basically not the council, and you want to propose a change, then you put a bond, right? You put like some deposit down, some amount of tokens. And what this is meant to sort of suggest a degree of popularity, right? The more this bond, the bigger this bond is, the more the tokens are locked behind this proposal, then the more popular the proposal is, and the greater chance, basically the higher up the queue it gets. Yeah. And every now and again, every period, every probably 2 weeks or so, the most sponsored proposal, so the one with the most bond behind it, the one with the most tokens locked up in it, is the one that gets tabled for a vote. And at that point, the tokens become freed up. Anything that's been proposed, well, anyone else can bond more tokens behind it. So everyone is free to sort of push a proposal forward and get behind a proposal that they think is sensible and deserves to be voted upon. Once it goes to referendum, and we have a period, probably again a couple of weeks, where voting can happen. People can sort of suggest that, yeah, actually I'm going to back it with my tokens, but they're voting. Now, as I mentioned before briefly, we have not just stake-weighted voting, like you would expect with a typical coin vote, but also locked duration voting as well. So you don't just put your coins behind it, but you also say, well, I'm going to, if this goes through or doesn't go through, if you're saying no, then I'm going to actually offer to lock my coins up, so I can't move them, I can't sell them, I can't do anything, I can't transfer them for a particular period of time. And the longer you're willing to lock your coins up behind this proposal, then or against this proposal, then the more your vote carries, the louder your voice is heard. In principle, so only the winning voters' tokens are locked. So if you vote no and it ends up being yes, or vice versa, then your tokens don't get locked, right? Because you lost. So why should you pay the price of having your tokens locked? It's only the winning side that have their tokens locked, and they're only locked for as long as they offered. As I mentioned before, there's a supermajority required of the total sort of voting power for any turnout that's below sort of 100%. And critically, any winning motions are autonomously, irreversibly enacted after this period, right? So probably the cooldown period would be about 2 weeks as well. So after this 2-week period, it gets enacted. So you've got 2 weeks of things staying as they are before you have to, basically for you to be able to divest yourself if you think it's a really bad idea. If you voted against it and it goes out, it ends up becoming passed, you still have 2 weeks of the old system that you can use, that you can divest before the change happens. And this is to protect the minority, basically. This is to protect minority voters. As I mentioned, the delayed enactment. So what we want to do is avoid, the reason that we do this is to avoid sort of irresponsible voting practices. The most irresponsible one, of course, is selling your vote. So if I'm not locked in, if by voting I don't get locked in to my decision for a period of time, then it means that I can sort of sell my vote and then immediately sell the tokens if the vote goes the wrong way, and I don't really lose anything more than anyone else. And that's problematic because it means that everyone then has an incentive to sell their vote. Whereas if by selling your vote, your token, someone votes with that token, and then they effectively lock your token up, that means that you can't exit, whereas people who lost the vote can exit, and that massively reduces that increases your cost of selling the vote, and therefore drives the price of buying votes up, which is what we want to do. The rest I already mentioned. Roughly speaking, it's a very simple, at least at this point, it's a very simple proposal. It's just that tokens are multiplied by the time that you lock, and we split time up into periods of 2 weeks. We have a maximum of 12 weeks, which is the period that validators have their their tokens locked up for the guys that validate on the validate the network. And validators, obviously, because they've got their tokens locked up for the full amount anyway, automatically get the maximum multiplier. So if you lock up your tokens for 2 weeks, then that's worth a sixth as much as if you lock your tokens up for 12 weeks. Here's a simple example. So Alice, whom has got 1 token, but she's willing to lock it up for 8 weeks. So because we split it into 2-week blocks, there are 4 blocks. Bob has 3 dots, but he's willing to lock those 3 dots up for 6 weeks. So that's three lots of 2 weeks. So in principle, it's 3 multiplied by 3. So that's 9 blocks of token time, if you like. And Charlie has 4 dots, but he's not willing to lock it up beyond the minimum amount of 2 weeks. Now Alice and Charlie are both voting no. They're both against the motion in this example. Bob is voting yes. He's for the motion. And if we add them up, then we see that the no votes, there's only 8, whereas the yes votes win, there's 9. So the losing side, the no votes, remain unlocked. They don't get locked at all, whereas the yes votes become locked for the period, the 6 weeks that was offered. And we can see the there we are, the time as the time passes. The vote ends at week 0. Bob's tokens are locked all the way up to week 6, and the proposal is enacted at week 2. So in principle, Alice and Charlie, the no voters, can exit the network and sell their tokens if they want in the first 2-week period before anything happens. If we move to the second example, in this case, Bob still got his 3 dots, but is only willing to lock it up for 4 weeks this time. So that's 2 2-week periods. So now it's actually 8 versus 6. So the no votes win. Alice and Charlie are locked. Their tokens become locked. And Charlie's are only locked for 2 weeks because he only did it for 2 weeks. He had 4 dots, but only 2 weeks lock. Alice, on the other hand, 8 weeks lock. So that's 4 blocks of 2 weeks. So the vote ends. It was rejected. But in principle, these guys still can't move their tokens out of the network. And what this does is it means that if there's some issue with the network, where something actually does need to be changed, and it's time critical, then it costs Alice. Alice now has to have her tokens locked through this issue period, whereas the yes voters, the ones who want to fix the issue, for whatever reason, they can actually sell out. They can sell and they can move their tokens onto another network if they think it's needed. Adaptive quorum biasing is a means of avoiding a strict and arbitrary quorum. So if you're familiar with if you've done any voting, then you're probably aware of this sort of idea that there has to be a minimum number of voters before the result should be respected. So if only one person comes and votes out of 100 people, then it's like, well, doesn't really reflect perhaps the will of the population. What I didn't want to do was introduce strict quorums into Polkadot. There's a few issues with strict quorums. First, you have to actually choose what the number is, which is really not very easy, especially when you've got something as volatile and untested as a blockchain governance system. But moreover, there are game theoretic issues with whether it's worthwhile coming out and voting as potentially the minority, because if you're the losing side and you vote, then you might end up pushing the quorum above the sort of amount needed for the yes votes for your opposite side, the one that you don't want to win, to actually carry and win and get enacted. So there are issues. What we do with adaptive quorum biasing is we say, well, if everybody comes and turns out, then it's just a majority, right? So it's just 50-50, it's like whoever gets 51% or more of the guys that come out. But if it's lower than the total amount of people, so if fewer than the total voters come out and vote, then it's a little different. And in that case, the fewer the people come out and vote, the greater the majority must be. So if only sort of one person comes out and votes, well, let's say 2 people come out and vote, then the majority must be huge. So if 2 people out of 100 come out and vote, then basically they both have to vote yes before or it won't go through. If one votes yes and the other votes no, then it won't go through. If 3 people out of 100 come out and vote, and 2 vote yes and 1 votes no, then it still won't go through, because the majority isn't big enough, right? It has to be like a massive supermajority at that level. The specific equation used is basically I votes, yes votes, you don't know, multiplied by the square root of the turnout. And the turnout is a fraction here, right? So if the turnout is 1, which means everyone turned out, and the square root of 1 is 1, then it's just multiply anything by 1 and it's the same thing. So it's just literally yes votes must be greater than no votes. So when everyone comes out, it's just a simple whichever one had the more votes. But as soon as there's less than 1, right, as soon as fewer than the whole population came and voted, then actually the I votes get a disadvantage, and there have to be more of them before it will actually pass and go through. We also invert it, and that's what I mentioned earlier. So when the council puts forward a unanimously approved proposal, then we actually invert it and we require we put the disadvantage on the no side, on the default, on the status quo. Yeah, and it's those that have to have the greater amount of votes, the super majority, before it doesn't go through. Here's a graph that sort of gives you sort of some idea of how it works. So basically, here's the line 50-50, right? And what this is, this represents the number of yes votes required in order to actually carry it through. And it's only really needed, you only need to look at the orange line. The green line is the sort of inverted version. So the orange line is for normal public proposals. So if you get 100% turnout, so over on the right side of the graph, then the number of yes votes that you need is 50, right? 50%, yeah? Because you need at least 50% of the guys coming out to carry it, if there's full turnout. But as there becomes fewer people who come to turn out, then the number of yes votes that you need goes up, yeah? And it goes up and up and up and up and up and up and up, until eventually, if only one person turns out, then it has to be, well, let's say a handful of people. Technically it also is with one person, but that's unlikely to happen. If only a handful of people turn out, then it has to tend towards 100%, and it very sharply tends to 100% at that point. So basically, if at the point that only 50% of people turn out, then we're looking at something along the lines, I don't know, what is that, about 58, 59% of the 50% of people that turn out must vote yes. If we go down to 25%, so only 1 in 4 turn out, then I think it's 67% that need to be yes. So we have a typical supermajority required at 25% turnout. And if we go below, if we go to like 12.5%, which is approximately here, then we get to 75%. So basically 3 in every 4 votes must be yes before it carries, and so on. And it turns out that these numbers, as you can see at the side, are actually pretty decent. They sort of make reasonable sense. They're quite sensible. And there's another graph that shows pretty much the same thing. So the council is a delegated body for, as I say, defaulting these decisions. So the council more or less determines the default. It can go 3 ways. If the majority of the council, but not the unanimous, not all of them, just the majority, believe that it's a good idea, they approve of it, they approve of the proposal, then it's just a simple majority referendum. We don't do any of that quorum biasing, right? It's just a majority. It's just like, are there more yes votes than no votes? Yes, okay, then it passes. If it's a unanimous council, then it's a negative turnout bias, which means at fewer than 100% turnout, we actually force the no votes to be a supermajority before it doesn't pass. If the council just don't bother, they don't like it, it's not a majority, right? It's a minority of the council that approve a proposal, then basically it has to be a public referendum, and at that point we do the quorum biasing in favour of the no votes. So basically you have to have anything less than 100% turnout, you have an increasing requirement for there to be a supermajority of yes votes. And finally, when we get to the a unanimous council, if there's for some reason there's a referendum that's a proposal that we consider is actually bad, right? It's got a flaw of some sort, or it's malicious, then if the council band together, if they all agree, unanimous, so if it's uncontroversial that this thing is problematic, they can also cancel a referendum, right? So they can say, no, I mean, you may have voted on it, but we believe this is actually dangerous and it's problematic for the network, and we will take an executive decision, a sort of emergency decision, and cancel it. In principle, a council member can also veto a single council motion, but they can only veto it once, right? So if the council then proposes that motion again, there's a cool-down period of something like 2 or 4 weeks. And if they propose that thing again, they can't veto it anymore, right? So it's a one-off veto. And what this is designed to do is, if a council member really disagrees with a motion, they think it's a really bad idea, but the other guys think it's a pretty decent idea, then they can basically say, look, I think you should rethink this. You have to have another 4 weeks to rethink this. And if after this period of time they still think it's a great idea, then yeah, so be it. But it allows for that kind of that safeguard, that safety net of reconsideration. The elections at a council, I'll just go over this very quickly, but the elections are staggered 1 seat at a time, so there's 12 seats on a council, maybe 24. They all come up once every couple of weeks, right? And it rotates. So basically, after about a year, then all of the council members will have had their seat rotated, and there'll have been a new vote for their seat. So basically, when you get elected to the council, you last about a year before your seat comes up for re-election. Now the actual election voting mechanism is quite nice. It's an approval vote, which basically means when you take your tokens, you can approve as many of the people who have put themselves forward for election to the council as you want. You can approve all of them if you want, but that's kind of pointless. That's the same as not approving any of them. You can approve all but one of them, which basically is a vote against that one. Or you can just approve 1 or 2 of them, which is sort of a vote for those, but not a vote for anyone. So you can vote for as many as you want. Those votes, assuming that these people you vote for don't get in, if they're not the top most approved candidate, then they still stick around, or at least the top 10 or 20 of them still stick around until the next vote, and they keep all of the approvals, right? So they keep all the votes. And what this does is it means it's kind of like a collection process. You collect approval votes as people vote, which they probably won't do literally every time the seat comes up. And so you collect them, and eventually when you get enough of these votes, then you get elected to the council. And that's kind of designed in order to keep the council rotating, keep some degree of fresh blood in it, and sort of mitigate any the problems of the same old sort of people just continuing to sit on the council that you typically would get if you do something like a more parliamentary system, where you just have a vote every couple of years and all of the seats come up for voting at the same time. There's also bonds introduced in order to mitigate any problems with civil attacks, where an awful lot of people vote and just end up with a wash of candidates and no one really knows what's going on. Longer term, we do plan on introducing additional, more sophisticated governance inputs. Whether these become hardwired into the governance system, or whether they're more signalling mechanisms that don't have any hard power, but maybe soft power, maybe the power to temporarily delay proposals being enacted, is still up for discussion. But sort of medium term, medium difficulty proposals would be having long-term node operators, having some sort of position within the governance system that we'd do by basically tracking nodes being online as part of some actual kind of inbuilt protocol mechanism, sort of sent nodes off puzzles every now and again just to check whether they're actually listening. Parachain operators, which would basically mean, oops. Okay, I'm going to have to do the rest of it from memory. Parachain operators, which would, yeah, it's run out of power.
Oh yeah, no power.
Yeah. Which would basically mean the each of the parachains that are being hosted by Polkadot would need to put forward some opinion on a proposal. They'd have some degree of power in order to, whatever, delay a proposal or vote on a proposal or vote on a council member, whatever it'll be. And also users, and this basically comes down to transaction fees. So in principle this would mean that as transactors within the Polkadot network, probably just on the relay chain, because parachains can basically do whatever they want, but as transactors on the relay chain, the more transactions you put out, in principle the greater the voting power you would have. And in principle we can also, longer term, think about trying to get on the opinions of like dApp developers and implementation teams. But these are much harder. They require oracleization, so basically they require some probably potentially game theoretic mechanism, potentially just some sort of third-party oracle, to actually name each of the significant dApp development teams and client implementation teams. Beyond that, I was only going to mention our rough roadmap. So, in terms of substrate, we're working towards our beta release of 1.0, fairly substantial milestone that we're super happy to have out. This will probably happen in the next week or so once we've put the finishing touches on our consensus algorithm. After that, we're aiming to release 1.0 final sometime in the first quarter of next year, and this will basically have some internal auditing done on it. We'll have a few API tweaks, we'll have a bit more polish, but basically we'll be more or less ready for people to start rolling networks out on, especially sort of lowish value networks. Never mind. With regards to Polkadot, we're moving towards POC, proof of concept 3, which will have parachains in it, much as POC 2 does, but we're hoping to actually build on this and actually have lots of a few more actual parachains deployed onto POC 3. POC 2 don't think it had actually any on there. Governance system, which most of which I've just talked about, and the new consensus mechanism, the hybrid consensus with Grandpa. That we are also aiming to release this month, so probably shortly after the 1.0 beta for Substrate. As far as next year goes, our plan is to release POC 4 that will have interchain messaging sometime in the first, well, probably, I'm not going to say first quarter. We'll you know, obviously in our heads it will be in the first quarter, but realistically it's probably going to be sometime in April. And Substrate 1.0 final, as I mentioned, and the second half of 2019, as Ryan said, is where we're planning to actually put out the 1.0 of Polkadot, assuming the audit goes well. Cheers! That's all I have to tell you for now. I'm going to give you over to Rob, I think, next.
Okay, thanks so much. Thanks so much. You're welcome.
Q&A, right. I'm thinking of doing a short story and then Q&A with everyone at the end.
Thanks so much, Dr. Gavin. まさにテレビとか YouTube とかで見るような内容が話されてたので、僕自身すごいワクワクしてました。で、今話されてた内容も多分決して優しい内容ではないと思うので、ここで10分間休憩を取りたいと思います。で、この間にお手洗いとか、あとわからないところとか、隣の方々とお話ししていただいて、で最後にQ&A セッションも設けているので、そこでどんな内容が聞きたいかとか考えていただければいいなと思います。じゃあそれではここから10分間くらい休憩に入ります。35分からまた始めようと思います。
通訳じゃなかった。そう、通訳しなくていい。通訳するのかなと思って。この内容の通訳させられたらさ。
my other side. Other side.
Yep. This is the clicker. Maybe. これウォークする？ウォークしないよねこれだと。
二重につなげるってことですか？
うん。
ちょっとやってみる。
OK。
あとパソコンの方で向こうのアップル TV。
これでできますよ。
これで一回画面でここでアップル TV っていうのをちょっと確認してきます。
パスワードは？
アップル TV 映ってますか？
映ってないよ。
映ってない。
それ使います？
映ってる。
これ。
これは中央のもの。
ああ、そっか。So we cannot connect this one. So you have to put this one.
What do you mean? You can't connect it.
So you cannot use speaker.
The clicker. This is the clicker, right?
Yeah. Yeah. You can use. Sorry.
はい、続きましてロバートの方からポルカドット for Developers ということでデベロッパー向けの、ロードマップとか開発の現状についてシェアしていただきます。ロバートはポルカドットのコファウンダーでティールのピーター・ティールフェローという世界の若者の天才起業家20人のうちの1人にピーター・ティールによって選ばれている、逸材です。それではよろしくお願いします。So, please welcome.
Yeah, thank you very much, everyone. Thank you for coming. So, you already heard in the first two presentations, first from Ryan, about basically what's our ideology. What does Web3 mean? What exactly is the long-term vision we are trying to build? One huge part of that is how is such a system governed? I mean, I can get into the technicals for a very long time, but over the course of years, or even as short as months, there are going to be upgrades that need to be made, crucial decisions that need to be decided upon. So Gav described how our governance is going to work. I'm going to go into a slightly different direction and talk about what Polkadot means for developers, or more broadly for developer teams. So we're describing this technology that we think is great. We're putting a lot of work into it. But the question that may be on many of your minds, especially if you lead a team that is interested in working on Polkadot, is how do you actually do that? So that's what I'm going to go into today. As a bit of a prelude, I want to note a few of the observations that guide us. So one is that one size doesn't fit all. The general purpose isn't necessarily good enough for the kinds of apps that you want to build for Web3. We've seen a lot of different blockchains being deployed, but typically in a very general purpose manner. What we think is really important is that you can make room for specialization. The idea that, for example, in many smart contract platforms, you're paying fees based on every single tiny instruction that you perform. So add two numbers together, then stop, pay a fee. Multiply, stop, pay a fee. And it's these tiny little steps are causing huge inefficiencies in the amount of computing that you can do. So if you allow specialization in computation, that you can do coarser-grained computations, or perhaps in storage formats, then you can get algorithmic improvements in what you're doing. And this specialization is really key, especially when you can have specialized services that talk to each other. And then all of a sudden you have some general pieces that are using specialized components to do the bulk of their heavy lifting, but those can actually be stitched together. Unfortunately, right now we are facing a bit of a fragmented landscape. So the idea of Polkadot is to pave way for new blockchains to come around that do specific things, but also to integrate those that are already there. So there's this fragmented landscape. We want to deploy a relay chain that allows those existing chains to be bridged to it, but also that new specialized solutions can be deployed, and that you can write Web 3.0 enabled applications that actually interoperate with any and all parts of that. So our design principles are that Polkadot should be heterogeneous. We want to support an ecosystem of diverse and complementary utilities. So things that work well together and are completely different. That it's scalable. So this is definitely a big problem that people have noticed over the past year particularly, is that blockchains right now aren't scaling that well. They can't do that many transactions, or if they can do a lot of transactions, typically those transactions are very simplistic. So we want the ability to do lots of fairly complex computation. So you can do that scaling on-chain with specialized solutions, but also incorporating off-chain scaling, things like state channels or plasma and those sorts of things. One key part of what we're doing is that we want an ultra-efficient root layer. Imagine if you come up with a new design that is 100 times more efficient than the old design, but your implementation is slow. So if you have a slow implementation, it's kind of slowing down all the other gains that you've produced. So what we really focus on is writing fast code. And of course that it's secure, that we do formal proofs of security properties, that we prove that economic incentives are aligned in a formal manner, and that it's not something where you just sort of hand wave away and you say, oh well, these people are going to interact in this specific way. We don't assume honesty, we only assume rationality. So just to think about what really goes into a blockchain, there are two sides of it. I think this is a good way to think about it, that there's a state machine and consensus. That those are both halves of it. So state machine is describing actually what are transactions. It could be simple money payments. It could be smart contract transfers. It could be starting off-chain state channels. Basically, a state machine is an abstraction that encapsulates any kind of work that you could do. Consensus is how do you agree upon which transactions actually occurred. So usually when you have an idea for a blockchain, you have an idea for a new state machine. Some new way of processing transactions that's going to be more efficient or serve some particular purpose particularly well. So you don't usually in that case really care exactly how the blockchain you write is going to be secured. However, historically, teams that did have a new way of processing transactions also had to write all of the consensus as well. So that's taking a lot of time away from developer teams because they can't focus on what their primary interest and their primary innovation is. So what Polkadot's goal is to do is to allow you to focus purely on the state machine side of things. That consensus and agreement is inherently provided by the relay chain, and that you just have to write your state machine. You can focus 100% of your time on that. It should lead to a lot of duplication of effort between teams, and it should lead to faster innovation in the long run. So the other big part of what we do is interoperability. We're connecting these chains, particularly with distinct state machines, sometimes with distinct consensus. For example, when we bridge something like Ethereum, Ethereum provides its own consensus algorithm. We have to allow this to interoperate as well. We want to support the past, the present, and the future. So basically, what has been deployed already, what we believe are the limits of current chain technology, the current limits of the research, that would be the present, and also the future, that we want to support stuff that hasn't really even been thought of yet. So it means that we're working in a very general abstraction layer for how we actually describe parachains, whereas the parachains themselves can be very specialized. And this is sort of what Gavin was talking about with the runtime upgrades. Essentially, you can deploy a chain with a specific runtime that does one thing, but as new research and new optimizations come along, you can upgrade the entire logic of that chain without a hard fork. So that's sort of one of the things that we consider when we talk about interoperability as well. We also think beyond tokens in terms of what interoperability, what value you can gain from interoperability. So moving tokens between chains it's very easy to see the value in that you could hold Ether or Bitcoin on other chains, that you could have tokens defined on one parachain that are used in decentralized exchange on another parachain. That sort of thing is quite easy to see the value in. But we also focus on arbitrary message passing. So that means chains can send pieces of data between each other that could mean that they're transferring tokens. It could also mean that they're doing smart contract calls across chains. So you have one chain dispatching a message that leads to some logic being executed on another chain. So what you could do, for example, there is something like have a file storage chain. And every time that file storage chain's bond is about to run out on some file or piece of data you're storing, it sends a message that calls a smart contract on a smart contract platform that then re-tops up the thing. So all of a sudden you have this feedback loop with the file storage lane being really specialized. And this is what the security model of Polkadot basically looks like on the relay chain. Is that rather than chains competing amongst each other for security resources, they collaborate essentially. There's only so much stake and so much mining power to go around. One common consideration that people run into when they're building their own blockchain is, okay, how the hell do we get miners on this system? How do we attract enough stakers so that the thing can't easily be 51% attacked? So with Polkadot, essentially, you're having all chains pool their resources to provide security over each of them together. And this leads to a more secure system in the end. Now I'll talk a bit more about how do you actually build on Polkadot. So the technologies that we're using are, at least for the core, we're using for Rust. For Substrate, we're using Rust. The Rust programming language is sort of in the same boat as C and C++. It's very low level, but it's very modern in the sense that it can prove that certain classes of very security critical errors can't happen at all, which is extremely useful for our case. WebAssembly is a cross-platform. It's platform agnostic, very fast virtual machine. It can be it's optimized for compilers. It has very good compiler support and browser support. It's just generally going to be one of the biggest things in the near future. And libp2p is used for parachain networking. Obviously, you can choose sort of what you like for parachain networking, but we found that libp2p at least is a nice set of tools for making complex protocols. So what a parachain really boils down to, if I had to say exactly what a parachain is and how you define it, you have this validity function. So it's a piece of WebAssembly code, basically, and the code is stored on the relay chain. That's a parachain. That's the definition of a parachain. The job of a collator node, so a collator is analogous to something like a miner or a staker in current systems. So their job is to sit around, listen for transactions, and then put those transactions into a block. And their goal is to come up with a block that makes the validity function evaluate to true. That makes the validity function say this block is indeed valid. So that way, the collators are actually doing the heavy work of creating the block, and the validators don't need to actually really themselves understand how the parachain works, but they get this verifiable way of checking if the block is actually correctly constructed. And the last thing you have to think about is that there are message queues between each parachain to every other parachain. So this is sort of what the Polkadot set of chains might look like. Part of this is actually introducing this notion of hierarchicality that I think is very interesting. We've talked so far about Polkadot as being a platform for connecting different parachains to it. But what you can see here is that you have the relay chain, you have a few chains under it. Some of them are bridges, parachains like Zcash, you have WASM smart contracts, and another thing that you can have is actually, and this is what Gav alluded to in his talk, is that you can deploy Polkadot itself as a parachain to Polkadot, theoretically. So this is long-term our vision for massively increasing the scalability of blockchain networks, is this sort of recursive sharding of Polkadot. And what we've built with Substrate in two parts: one, allowing Substrate to build Polkadot, and two, allowing Polkadot to be used as the consensus mechanism for Substrate chains, means that there is a reasonable avenue towards this hierarchy of chains. So what Polkadot actually looks like as a developer when you want to write one of these chains is you write the validity function. It's really just that function. You can do a lot of work within there, and we have libraries for common utilities, things like balances or certain staking protocols, or even the governance stuff that Gav mentioned. You can basically plug into your own chain as well. When you're writing your runtime, the runtime being the actual business logic of the chain that executes the state transition, that decides whether transactions are valid, that's in WebAssembly. And when you write your collator node, which is probably, if you were to do it from scratch, the most difficult part of writing a parachain. It can be done from scratch if you like, but if you do it with Substrate, you basically get the collator node for free because there's already utilities in there for authoring blocks, transaction queuing, and peer-to-peer networking. So I'll skip these because Gav has already talked about that. Just to go really quickly into this diagram again, we have libp2p coordinating a consensus process between nodes that executes WebAssembly code called a runtime that's consisting of many modules. So these modules can sort of be pre-packaged, distributed online on some kind of repository, or you get them from GitHub. So certain common things you may not need to write yourself, again, reducing duplication of effort. Or, of course, you're going to integrate those with the ones that you write for your specialized parachain. So that means you'll focus, again, on your specific piece that you're actually innovating with. And one module that we wrote, for example, for Polkadot is the parachains one. So what parachain development would look like if you wanted to write on Substrate was you would select a set of modules for some functionality that you like from the Substrate runtime module library, or SRML for short. So that would be for things like, again, balances or maybe smart contracts or those sorts of things. Then you would write your parachain specific modules. So the special thing that your parachain is supposed to do. For example, file storage or oracles or machine learning or Internet of Things. And then Substrate just lets you link those together. You would choose parachain consensus as your consensus algorithm to say, okay, this chain is intended to be deployed as a parachain. And basically, that would be it. Governance, Gavin talked a lot about that. I think the one main thing I want to highlight is that the governance is self-upgrading, that it's, again, on-chain governance, and in particular, that just to touch on this point that Gav mentioned briefly towards the end of his talk, that parachains may have the ability to cast votes. Because when you register a parachain, you're putting up some leasing bond to rent the slot. There's maybe, there's dozens of slots for parachains on the relay chain with current limits of the research. So when you've gotten one of those slots, you've put down a security deposit essentially that ensures that your parachain has that slot. So it could be that your parachain actually has logic for deciding how to spend that bond in governance, which means it opens the floor up to many different kinds of governance mechanisms. You could have parachains that actually do hash power voting or experiment with radical markets like quadratic voting, those sorts of things. So even things that are not strictly defined within the Polkadot governance system can be programmed within parachains. So I'll just spend the last portion of this talk going quickly over the roadmap from a developer perspective. So what we did in Proof of Concept 1 was the governance, most of what Gavin had described. We did staking, we had a basic user interface, and the forkless upgrades. Upgrading the logic of the chain without hard forks, which we used to switch to Proof of Concept 2. So Proof of Concept 2 was the initial parachains implementation, and we wrote a couple dummy parachains, sort of basic example parachains that we deployed on that network. So now we're moving on to POC 3. That's going to be released just after Substrate 1.0 beta. It was mostly about the hybrid consensus algorithm, so that you have this novel consensus algorithm that we invented in-house, which is meant to allow for maximum efficiency in terms of throughput and also finality. It's called Grandpa, and that was the main feature of Proof of Concept 3 in terms of actual functionality that differs from POC 2. But there's sort of a shadow feature for POC3. So the shadow feature for POC3 was the time that we spent getting Substrate to support pluggable consensus. So the fact that Substrate supports pluggable consensus now means that we can write this parachains consensus algorithm, and all of a sudden now you can write parachains with Substrate. So that's very near on the horizon. Previously, as of POC2, you had to write parachains without Substrate. So now we're bringing basically the power of Substrate to parachains very shortly. So what's coming up next is Proof of Concept 4. So that'll be the first implementation of the interchain messaging protocol. Ideally January, but probably there will be some delays along the line, although I hope not too much. So at this point, after POC 4 is actually a point that I'm very excited about, because it's where I would say it's roughly complete for developers. So if you have a developer team, this is where the APIs have more or less stabilized. Nothing that really changes beyond that point in POC 5 or perhaps the further period leading up to the release of the mainnet in Q3 2019. Nothing beyond POC 4 is really going to significantly affect the development process. So everything beyond POC 4 is, for example, going to be adding implementations of features for economic safety that we've described on paper but just haven't written the code for yet. So the POC 4 testnet is going to support interchain messaging, so you can basically write parachains just as you would on mainnet. And in parallel, we're going to be working on Substrate basically to make this more and more usable. So I'll wrap it up there. Thank you very much.
So, thank you, Robert. はい、ありがとうございました。ちょっと時間が押しているので、次、コモンウェルズラブの、ディランデカの方から、ショートライトニングトークをさせていただこうと思います。やっぱりガバナンスモデルっていうものが、先ほどギャビンのセッションでも、ロバートのセッションでも、言われていたと思うんですが、それをグローバルにいかにスケールする形で、プロトコルレベルでやっていくかというお話をしてもらいます。
Keys on your. Does this even work? Okay, cool.
Does it work?
Cool.
Okay.
Oh wait. Oh, this screen is like.
Oh yeah.
Yeah. Yeah, but.
Never mind. I think it's okay. You can do it.
Yeah?
Yeah.
Okay. Alright. That's fine.
拍手お願いします。
Hi everyone. Thank you for sticking around. I know everyone's really hungry, so I will be very, very quick. So this is Edgeware. I'm Dylan Chen. Nice to meet everyone. So Edgeware is built by Commonwealth Labs. We're built on Substrate. We're a team based in the US, New York, San Francisco. And so as Ryan mentioned before, we're still in the early days of decentralized governance. And so that requires a lot of experimentation. As Ryan mentioned before, the kind of production chains, Ethereum, Tezos, Dfinity, and Polkadot, have to be a little bit more conservative given that they already have or will have high-value networks, right? And so for any kind of experimental things, we kind of need to play around with these. And so the place where that needs to happen still needs to have a little bit of flexibility, but it also needs real incentives, right? And so it can't just be a test net that doesn't trade on exchanges. It needs to be right in the middle. It should be a staging network. And so that's what Edgeware is. And so Edgeware is a WASM smart contract chain, and it is that test net for active governance or kind of new tech. It could be core tech, it could be scalability mechanisms, it could be new governance. Really anything you can throw at it should be tested on here after it's been talked about on forums and incorporated here and then exported to other chains. And so it should improve itself. And there's a bottom slide that says community token distribution, which I'll get to later. and that's Edgeware, and it's all built on Substrate. And so we actually announced at Web3, and since that time, when was Web3? It was like October, so just over, I would say like 6 weeks ago is when we announced, and since then we're going to be shipping a live testnet in essentially a week or two, knock on wood. So everyone can kind of play with that, and please feel free to reach out to me or at the information at the end of the slide to kind of play around with that. And so from Substrate, we inherit all the kind of goodies, right? It's a WASM smart contract platform. It's the new tech from the Shasper chain that potentially gets implemented. And in return, what we give back to the parachain ecosystem, the Polkadot ecosystem, is a bunch of cool voting tech, right? And so what we're building right out of the box is an identity module to kind of inherit or consume identity claims. So that can start to experiment with 1P, 1V type voting instead of just coin holder or coin weighted voting. We have delegation, so that's like liquid democracy. And I won't dive into that right now. And in addition to that, we actually have a thing called the lock drop. And so with that, we're building a bridge from Ethereum to Edgeware itself, right? And so this is a federated bridge, and it's all available on GitHub right now. So this is just looking back at what we kind of are building out for Edgeware. So on one side, it's this set of DAOs, treasuries, votings, and then whatever is here, I don't even remember, as well as the dev tooling that should kind of arise from building Edgeware and supporting that chain. And so the biggest question we want to ask on here is, can we actually build a compelling kind of solution for competing with centralized organizations? So what we get from building on Edgeware. So this is just kind of a recap. We get a WASM toolchain. We get active governance right out of the box, and we get a clear path to upgradability by building on Substrate, where we'll be first a solo chain, then link to Ethereum through this bridge, and then finally, as POC 3 and 4 roll around, will be integrated right out of the box to Polkadot. And so this is kind of where I'm personally interested in, is the block reward that gets allocated to different funding groups on the network itself. So within Edgeware, we've developed this concept of, we haven't developed this concept. There's councils, right? And in Edgeware, we have sub-councils. So core devs, dApp devs, end users, validators, they're all represented. And so each of these groups gets to control a portion of the on-chain treasury. And so it should work like a DAO. You vote on different mechanisms or different proposals, you fund them, and then they should be built, upgraded, and then voted on to be implemented on the Edgeware chain itself. So how do we actually seed this kind of whole Edgeware chain, right? So that's kind of a big question. So we're actually not doing an ICO or anything to keep in line with the kind of experimental nature of Edgeware. We're actually doing a thing called the lock drop. And so what that is essentially by time locking your Ethereum for 3 months, 6 months, a year, 2 years, you'll get a corresponding discount on the Edge tokens that you receive. You'll be minted this Edge, you'll get it, you'll transfer it on the bridge, and you'll be able to use it right on Edgeware. You'll also get your Ethereum back. And someone also told me that we should brand it as the most fair distribution since Bitcoin. I don't know if you can call fair or not. But we're giving away 90% of the tokens, right? And it's keeping in line with the kind of experimental nature that our philosophy of experimentation. And so you can reach out to us essentially, or participate in the lock drop Q1 2019. We're pushing a really aggressive roadmap. So the first testnet will come out by the end of this year, second testnet at the end of January next year, and a lock drop at the end of Q1, essentially. So please stay updated at Edgeware, or you can reach out to us at Commonwealth Labs at hello@commonwealth.im. All right, thank you so much.
Thanks so much, Dylan. はい、ありがとうございました。最後にQ&A セッション設けています。で、いっぱいたくさん聞きたいこと、分かんなかったことあるかと思うので、この際にぜひお聞きください。日本語でも英語でも大丈夫なので、遠慮なくご質問していただければと思います。ちょっと、準備します。Oh, yeah.
Just wait for the chairs. Yeah, I got it. Yeah.
Yeah.
Be careful. いい？あ、電気つけてもらっていいですか？ここから20分くらいちょっと時間が許す限り QA セッションの方やっていこうと思います。これだけのメンツが揃うことでなかなか本当に世界レベルで見てもなかなかないことだと思うので、ご質問、少しわからないことあった方はぜひこの際にお聞きしていただければいいかなと思います。はい、ご質問ある方いらっしゃいますか？じゃあ前の方からいきます。あ、日本語でも英語でも大丈夫です。
Is there any scaling solution other than multiple Polkadot?
So I'm a bit worried that there will be feedback here.
Yeah,
Is there any other scaling solution for relay network other than multiple Polkadot?
So parachains are meant to be the relay chain is meant to be a fairly minimal set of functionality. So it is really just about the parachains. But the parachains, basically, if you dive into the research, it's basically a quadratic improvement over existing chains, because you've essentially taken all computation off of the relay chain except for degenerate cases. So most of the overhead is just in maintaining message queues and maintaining availability of proof data. So it's quite a good scalability solution on its own. And parachains themselves may have their own scalability solutions, perhaps. They themselves would be sharded or provide some particularly efficient state channels or such implementation.
There will be many messaging between parachains, so the relay chain must be highly scalable.
Yeah, so the actual messaging is broken down into cheers. So the actual messaging is broken down into the data logistics, which is actually getting the messages from one set of collator nodes to another set of collator nodes, which the collator nodes operate on individual parachains. So it's basically getting the data from parachain to another parachain, but also on the security of that, so ensuring that the routing is correct and that data that arrives at a parachain did indeed come from a previous parachain in a recent block. Now the routing is actually a fairly easy problem, and even if you scale to the sort of level that we're talking about, which is about 100 parachains, even though technically you might then have 10,000 bits of routing to do, it's actually only 10,000 hashes to invert in a matrix. So it's actually fairly simple. The data logistics is substantially more difficult, but that ultimately boils down to networking, which is primarily about ensuring that the right set of nodes are, so that each node has the right connections to probably about 100 other nodes, and those connections need to adapt and morph as the validator sets change and are distributed to different parachains. That's a much more tough engineering challenge, but it's also a well-contained engineering challenge. It's networking, it's peer group forming and adapting, and it's something that we've, you know, has happened before, and we're reasonably confident is a relatively low risk, if somewhat tedious, algorithm to build. But yeah, like just sort of going beyond that, there are a couple of projects that are that look to be sort of building on, you know, sort of happy to be building on Polkadot, that are looking at creating a scaling solution beyond just having lots of parachains. Blink Network, who we're working with, are doing a something that can potentially scale to probably tens of thousands of transactions a second, very good for payments. And then we also have a notion of doing an implementation of kind of what we call a hub, a transient chain hub chain, which basically means it's something a little similar to Plasma, only using kind of slightly different, basically using short-lived blockchains that have few participants, and they come into existence for a relatively short period of time, allow transactions to happen, and then get resolved onto a hub chain, as I said. The other possibility that we're sort of keen to dream about, and I think this is kind of Polkadot v2, so this is probably a year or two after the mainnet release of Polkadot, is self-hosted Polkadot chains. So this is where Polkadot becomes, some of the parachains of Polkadot are themselves Polkadot chains. And so, as the very beginning of the talk I gave, I sort of mentioned that Substrate was used to build Polkadot, but also was used to build parachains that operate on Polkadot. And this will basically be one of the sort of key things that we focus on after mainnet release, and that will be turning Polkadot into a parachain. And when you can do that, then basically it means you can start building hierarchical trees of chains, rather than just have 100 that operate under at one level under a relay chain. And that, if you're willing to give up latency between sort of disparate leaves or disparate branches of the tree, which is pretty much inevitable, like it's not an unreasonable thing to accept, then you can in essence sort of scale fairly indefinitely. And by the time you've got like the third level down, then you're looking at, you know, millions of chains, and if each chain processes, I don't know, 500 transactions a second, then you're looking at 500 million transactions a second in principle, which is, you know, what at levels of sort of global transaction processing at that point.
I heard Substrate has a hot swappable consensus algorithm feature. Is it right? What is the purpose, and what is how does it work technically?
Okay, so the purpose, there's one particular purpose, which is to be able to solo launch a parachain. So basically have a parachain be an independent solo chain, so blockchain basically. And over time, after some period of time, allow it to morph into a parachain. So basically allow it to join Polkadot without having to be launched on Polkadot at day one. And we see this as being super important, partly because we want to be able to launch some of the parachains before Polkadot itself is launched, but also so that teams don't have to sort of commit themselves to Polkadot too early on. Basically, that allows them to develop on Substrate, launch their product, get some user base, and then basically sort of decide to turn it into a parachain. And it goes the other way around as well. In principle, we may end up with a team that wants to sort of that has a parachain, and they launch their product, and they're sort of like, well, things aren't working out, or maybe there's now multiple levels of Polkadot, and they want to move it from one of the top very expensive slots into a slot towards the you know, sort of 1 or 2 levels deep that will be inevitably less expensive, and it will allow that kind of degree of switching around. In principle, it can also be used for consensus protocol development, so that you can develop your chain on a relatively sort of basic consensus protocol, like our PBFT-based rhododendron protocol, and then over time switch it into your new consensus protocol when you're happy that your tests have gone well enough. Oh, and how does it work? Yeah, I'll let Rob do that.
Yeah, so it's not quite at the same level of generality as something like the runtime upgrades that we've seen. So with a runtime upgrade, you can actually swap out the entire code of the chain. What you can't really do with a hot swappable consensus algorithm is write a new consensus algorithm within the runtime. So consensus algorithms in the substrate model are always kept outside of the runtime, just because they usually require very specialized kinds of networking and connections between peers, to the point that you can't effectively do that at all within the WebAssembly execution environment. Yeah, so that's not convenient. So essentially, we have consensus algorithms that are outside of the runtime. So when you do a hot swap from one consensus algorithm to another, you're already assuming that the node software has the capability to interpret both consensus algorithms. So consensus algorithm A and consensus algorithm B. And from there, theoretically, it's actually quite simple to do. You simply issue a signal in some kind of well-understood format from the runtime, much in the same way that you would issue a signal that changes the runtime itself, that just says, when the block that issues this signal is finalized, the consensus algorithm will switch to the new one. And that's essentially how the feature will work.
How about data? How do you change the data? Or you don't change the data, or it's different data structure, or how? If you change UTXO to account more.
Okay, so this is that's more of a question of runtime upgrades. So consensus, at least in a very useful abstraction, is to divide between the state machine and the consensus. So the consensus just proves transitions from one state to another. So that could be UTXO transfers, or it could be account balances or something like that. Whereas the runtime upgrades may actually change what the logic of the chain is. So the way that this works is that the runtime can actually set new code to become the new code at the end of that block. And this new code might contain a procedure for either at the beginning of the next block or over a period of many blocks, migrating over the database to a new format.
All right, thank you.
他にご質問ある方いらっしゃいますか？
My question is about the governance. And I'm involved in a team where we develop DICO model. I guess you're familiar with the concept. And one of the problems that we have is that it's so easy for token holders to possess more than 51% of the voting power. And I think this is kind of a classic problem, because even in real life, if you look at the, like US politics, it's like economic inequality used to political inequality, right? So I was wondering if it's possible on your platform to prevent the rich from getting more than 51% of the power.
Not really, because money buys power. But
I mean, the equation that you had, like this both equal tokens multiplied by period, that can mitigate the risk, right? Because everybody can do that.
Indeed. So it's not possible to design. I'm gonna posit. I'm gonna sit here and declare. It's not possible to design a system that can resist any amount of money directed at taking it over. Right? It's just not possible. Any crypto-economic system necessarily will have a price. Just in the same way that as your man Shakespeare wrote, every man has his price, right? Every crypto-economic system has its price. But what we can do is we can mitigate, we can elevate that price beyond a sort of naive
minimum that we start at. So what I've tried to do with the Polkadot governance, and I want to stress that this is very much a sort of work in progress. I'm sort of declaring my thoughts as they move along and as I implement this stuff, but I don't see any of this as being perfect. I see it as sort of a sort of journey that we just have to sort of follow in order to arrive at hopefully something that's half decent. And one of the ways that you can mitigate this sort of coin holding thing is to require that the coin holders sort of stand by their decision for some period of time by restricting other aspects of it. Time is something that isn't possible to replace very easily. When you get older, you start to realize that. And I think it's also something that has been demonstrated throughout human history as being sort of very, very important means of signaling economically that there is some commitment to something. If you look even at religions, you'll find that some of the socio-religious cultural patterns, you'll find that the ones that have stayed, that have continued over for a long period of time, have some way of declaring, have some way to allow an individual to declare their membership of a group, and that typically revolves around doing something consistently for a long period of time. Whether it's growing your hair, sort of making your neck stick out very long, or there's all sorts of crazy practices that cultures have sort of managed to discover in order to demonstrate a commitment, and it typically uses time in order to do that, because time you can't be in two places at once. You can't both grow your hair and cut your hair. As such, I see that as being a really important ingredient in a governance system in order, as I say, to sort of give away, to demonstrate commitment. And one of the ways you can use time to demonstrate commitment is by locking up tokens for a period of time, which basically reduces your optionality on what you can do with those tokens. Now, it's still ultimately stake-based, which means if you have enough money, you can always override, you can just basically buy the market out and override everyone else's time-based commitment. But it does make it a lot harder. And what it means is that a small minority with a sufficiently large amount of commitment to the system can overrule a majority, a financially superior majority that doesn't have any commitment at all, that's just there to attack it, for example. And I think there's like a lot more that we can do in this regard. I think it's not just about sort of coin locking, but we can actually think about, for example, can you operate a node for a long period of time consistently? Can you, have you voted for a long period of time? Are you willing to give up other votes? Are you willing to take mutually exclusive votes for a particular period of time? There are all sorts of things that you can give up in order to demonstrate your commitment to something, or demonstrate your desire, the strength of your opinion on something that isn't necessarily just money. And that's, I think, that's an important thing.
I actually think it's worse than the current real life system that we already have, because in real life voting it's one person one vote, but on blockchain it's basically one token one vote. So what we are actually trying to do is to set up the cap for each person, and we could have a KYC, but once it's in a market, it was impossible to track tokens, so we no longer can tie tokens with identity. Do you think it's possible to, even if in the market, to tie the token with identity so that we can have
something we'll probably see some experimentation in Edgeware with is individualized non-transferable identity and potentially reputation associated with that identity over time based on some objective performance.
Which project is that?
That's Edgeware, which we were talking about a little bit earlier. And so, I certainly think there's opportunities to experiment with identity and reputation to to kind of mitigate the plutocracy argument as much as possible.
Yeah, I don't think I actually have nothing against a plutocracy if it delivers what it is that the users of the network want it to deliver. I think there's a lot of nonsense talked about what it is that governance should be doing. Certainly, if you look at some of my contemporaries on the Ethereum side, there's a notion that somehow governance is bad if there's only a relatively small number of decision makers, or governance could only work if there's a sufficiently large amount of inclusion or sufficiently large number of people that cast a vote. I actually think that that's complete nonsense. I think it's unfortunate that people take that position. I don't think they're thinking about it very hard, and I think they're automatically thinking that we need structures very similar to national governance structures in order to build sensible blockchains. I don't think that's the case. I think blockchains are purely economic systems, not places that you want to live, and as such they should more closely follow corporate governance mechanisms, which have nothing to do with one person, one vote. That would be complete nonsense. And the user base, to the degree that they have an effect on this, would be soft influence. So they would be able to, in principle, vote with their wallets. They'd be able to go to another network. They'd, in principle, be able to hard fork if they felt very strongly. And there'd be signaling mechanisms in order to demonstrate roughly what the user base considered. And if you measure your user base by transaction fees, then fine. If you measure your user base by one head, KYC, then fine. But it doesn't really matter because it's all soft signaling. But the actual underlying mechanism for making decisions should absolutely not be to do with like one head, one vote, because that will just imply that basically everyone's opinion is equal, which is complete nonsense. Everyone's opinion isn't equal. Some people are very well informed. Some people are have great track records of making good decisions. There's no reason whatsoever to believe that one person, one vote would give a really useful economic system that's that sort of delivers better than any of the other competitors. And we live in an increasingly competitive environment. It's not like I cast out and I say, right, anyone who's willing to give me a passport, please vote upon this coding decision I'm about to make with Polkadot. Right? That would be ludicrous. No, of course not. The Polkadot team makes those decisions, and people, if they believe that we're a good team, buys into Polkadot. But this is how I see systems continuing, and it's pretty much how, in principle at least, corporate governance works. If you believe the executive team is good, then you become a stakeholder, you buy into it, and perhaps the price goes up, right? And the company becomes, in principle, at least more successful if that corporate team is successful. This is the sorts of model that we should be doing, and we should be trying, less to build crypto utopia with crypto passports, and much more trying to solve the problem of creating systems that do the job and do it well.
I actually have more questions about it, but I guess I should.
Oh yeah, thanks so much. So maybe our last or two questions from backward.
I have a question to Al. What is Grandpa, and what is the difference between Grandpa and other existing mechanisms?
Sorry.
Hello? Anyone hear me?
Yep.
Okay, yeah, so Grandpa is a finality gadget. Somewhat like Casper, the friendly finality gadget. So the sort of idea is that we're going to produce blocks by something. We can do it by proof of stake, but it's going to be it's kind of proof of stake thing, which is a bit like how proof of work does it. In that we want block production to be very decentralized, lots of people to do it, and if we had that on its own, you could get probabilistic finality, which is has problems. So remember having to wait an hour for Bitcoin transactions to confirm because people wanted to make it extremely unlikely that they would ever be reverted. So especially if we want to talk to other chains, we need sort of provable finality. We need someone to come off and so what we have is we have a group of people signing and saying that this thing that we've already know we've agreed on is actually final. And so we do that by Byzantine agreement. Now we could do Byzantine agreement on every block, like Tendermint does, like Rhododendron currently does. Disadvantage of that is it doesn't scale very well. So either we have a few people voting on in the Byzantine agreement, and it's very centralized, or else it's very slow. Now with a fanatic idea like Grandpa, we can make that trade-off. It's fine for us to be a bit slower. Compared to Casper FFG, Grandpa is a bit more adaptive. It doesn't have checkpoints. We just agree on however many blocks we agree on, rather than every 64 blocks. And we tried to sort of abstract the problem a bit, so it's kind of much easier to apply it to arbitrary consensus mechanisms for block reduction.
So thanks so much. So unfortunately time is running out. So could you give us one comment about this meetup, or the comments about the Japanese community? Or like a feedback?
I think you're all great.
Like last conclusion or something.
Yeah. Well, it's I think from the questions, it's a really good way to get a handle. I mean, we've only been here a couple days, but we've already received like quite a lot of interesting feedback about, for example, our governance stuff. That you guys are catching on to the consensus stuff as well is very refreshing. Yeah, it seems like there's quite a high level of engagement here.
Yeah, it's always great to visit. Even back in like 2014, 2015 when I first came, the Tokyo community and also the Kyoto community actually was super well developed. There were lots of good questions. I went through, like if you remember, if you were in Ethereum back then, I went through like deploying a smart contract with Aleph0, this like kind of huge monster of Windows that you had to basically grapple with if you wanted to use Ethereum in the first 6 months or so of its existence. And it was great, you know. It was a full house. We had a good time, even though I was tremendously hungover from some of the Tokyo activities the night before. So yeah, no, it's a great community. I always love returning.
All right, so thanks so much. So we're gonna dive into the networking session. So I have ordered sushi and drinks. ネットワーキングセッションに入ろうと思います。お寿司を頼んだので、椅子の方をこっちの右側、左側、両サイドに寄せてください。ご協力お願いします。ご協力お願いします。この辺に。これが近すぎると。あ、近すぎダメだね。そうだね。これあれや、ミーティング